Welcome to the last session, that is session number 4 on module 4, that is disinfection. Myself, Vahiniyam, working as an assistant professor, Government Engineering College, Haveri. In the last sessions, we have discussed about the types of chlorination and definition for chlorination, and this session will take up breakpoint chlorination, residual chlorine, chlorine demand and some numerical problems. So let us take up breakpoint chlorination. Breakpoint chlorination is explained with the help of a graph wherein the x-axis is taken as chlorine dosage and the y-axis is taken as chlorine residuals or residual chlorine. Both are represented in milligram per liter or ppm. So for a water sample, when you add or when you apply chlorine in any form, so some portion initially it will be utilized for the oxidation of metals. Okay, so that point up to point A, the whatever the chlorine we are going to use or we are going to add, so that will be utilized for oxidation of metals up to point A. So therefore point A we will represent it as that point represents the oxidation of metals. When you further increase the chlorine dosage for the same water sample, so residual chlorines gradually increases. The chlorine residuals in the water sample gradually increases. And also the ammonia present in the water will be oxidized during this period. Okay. So the point B represents the ammonia present in water combines with chlorine to form chloramines. So up to point B, oxidation of ammonia will take place. Okay, and then as further the dosage of chlorine dosage increases, okay, so the residual chlorine drops down. The residual chlorine will be chlorine residues will reduce. Okay, why means the chloramines, whatever the formation of chloramine that has take place up to point B, so that will be destructed in this portion BC. Therefore the chlorine residuals drops down. Okay, so point C, at this point, so this is the demand. Okay, at this point the demand means the requirement of chlorine for disinfection of a water sample will be 0 at this point. Okay, so it will be 0. So if you add further, okay, beyond this point C, whatever you have applied, so that will be utilized for oxidizing organic and inorganic impurities, and beyond this point C, if you add the chlorine dosage, so that will be left as residual chlorine. So that will not be utilized for oxidizing any organic or inorganic impurities present in the water, because by the point C all organic and inorganic impurities will be oxidized. So beyond point C, whatever you are going to add as chlorine dosage, so that will be found as residual chlorine in the water sample. So therefore this point is called as breakpoint chlorination. So for all treatment processes, normally chlorine will be applied beyond this breakpoint chlorination. The sample will be analyzed for the breakpoint chlorination. After obtaining the ppm for this breakpoint chlorination, so it will be the water sample will be applied with the dosage beyond this breakpoint chlorination. Okay, so as I already told, it is 0 demand. So that means at breakpoint chlorination, the chlorine required for the treatment or required for the disinfection of impurities will be 0. Okay, at this point it will be 0. Therefore it is called as 0 demand point. Okay, and then beyond C, whatever the chlorine you have applied, so that will be left as residual chlorine. Okay, so this is the breakpoint chlorination. Okay, So how we can define breakpoint chlorination means it is the point at which chlorine added is entirely utilized by oxidation of impurities. It is the point. So at this point, till this point, whatever you have applied as a disinfectant, chlorine disinfectant, so the whole chlorine will be utilized by impurities for the oxidation. Okay. And also you can define like this, the point beyond this point free residual chlorine appears. So as I have already told, so the further addition of chlorine beyond breakpoint chlorination, so that will be left as residual chlorine. So therefore in the curve residual chlorine appears. At this point the residual chlorine is 0. Okay, so therefore beyond the point C it reappears. And then dosage beyond this point is same as superchlorination. So that means whatever the dosage you are adding beyond this breakpoint chlorination, it will be that is nothing but you are adding extra chlorine or extra dosage beyond the requirement. Therefore it is the same as superchlorination. So that is the explanation for breakpoint chlorination. Next we will take up chlorine demand. So it is the amount of chlorine that is required to react with all the impurities is termed as the chlorine demand. So I have already explained. So that means the amount of chlorine required by the sample to react with all the impurities present in the sample is called as chlorine demand. And also the amount of chlorine needed for free chlorine before free chlorine can be produced. That means it is chlorine demand is the amount of chlorine needed before free chlorine can be produced. So at breakpoint chlorination the demand is 0. So that means the chlorine required needed for the reaction of impurities will be 0. So at breakpoint chlorination it is 0. Okay, and then beyond the breakpoint chlorination free chlorine is produced. So if you apply, if you take a sample whose chlorine demand is say 0.5 milligram per liter. Okay, so then if you apply a dosage of 0.6 milligram per liter, then 0.5 is the needed or is the demand. So we have applied an excess of 0.1 milligram per liter. So that is nothing but that 0.1 milligram per liter is nothing but free chlorine. So the demand which is needed before free chlorine can be produced. So if you apply a dosage of 0.4 milligram per liter, then the whole chlorine will be utilized for the oxidation of the impurities. If you apply 0.5 exact 0.5 milligram per liter, then again the whole 0.5 milligram per liter of chlorine will be utilized for oxidation. When you apply 0.4, there will be still some impurities will be left in the water. But when you apply 0.5, all the impurities will be reacted or disinfected. And if you add 0.6 milligram per liter, then free chlorine will be produced. Beyond this 0.5 milligram per liter, whatever you are going to add, so that will be taken as free chlorine. So the amount of chlorine needed before free chlorine is produced, that is called as chlorine demand. And then it is also taken as amount of chlorine required for killing the pathogens, oxidizing organic and inorganic substances. Okay, it is the chlorine demand is the amount of chlorine required for killing the pathogens and oxidizing organic and inorganic substances. And then it can, why the chlorine demand appears means it is caused due to a water body due to rain. Okay, water body due to rain containing ammonia, or it may be due to addition of fertilizers to a water source. When the water source is infected by the water containing fertilizers, then it demands for chlorine. Okay, so that is the meaning of chlorine demand. How to find this chlorine, and polluted waters exert more chlorine demand. So if the polluted water, if the pollution or the impurities in the water is less, definitely the demand will be less. And if the pollutants or the impurities in the water is more, then the demand will be more. Therefore, to reduce the chlorine demand, the water has to be pre-treated. How to pre-treat it means either if you follow sedimentation or aeration, then chlorine demand can be brought down. Okay, because some of the impurities, organic or inorganic, will be taken off by the sedimentation process, hence chlorine demand can be reduced. How to find this chlorine demand means chlorine demand can be calculated as total chlorine added minus the residual chlorine present in the water. Okay, so chlorine, amount of chlorine, total amount of chlorine minus residual chlorine will give the value of chlorine demand. Next we will go for residual chlorine. What is this residual chlorine means? The addition of chlorine beyond breakpoint will result in free chlorine called as residual chlorine. It is the free chlorine available in the water source which may be utilized for further recontamination, okay, which may be utilized as a disinfectant for recontamination due to supply during the supply. Okay, so it is the addition of chlorine beyond breakpoint which results in a free chlorine is called as residual chlorine. And as you have observed, if you see the graph of breakpoint chlorination, it is proportional to the amount of chlorine added. So residual chlorine is exactly at 45-degree angle. Okay, so therefore it is directly proportional to the amount of chlorine added. So when you add a chlorine amount much higher than the demand, definitely the residual chlorine will be more. If you add it lesser than the demand, then the residual chlorine will be 0. Okay, if you add a lesser amount higher, that means the demand is 0.5. If you add 0.6, the residual chlorine is 0.1. If you add 1 milligram per liter, then the residual chlorine is 0.5 milligram per liter. If you add 0.8 milligram per liter, then the residual chlorine is 0.8 minus 0.5, that will be 0.3 milligram per liter. So that is what here, it is the difference between the amount of chlorine added and the chlorine demand. It is the difference between amount of chlorine added and the chlorine demand. And then most water treatment plants will add chlorine beyond the breakpoint. So as I have already told, why they go for residual chlorine means to avoid the recontamination. If there is some residual chlorine in the water source which is to be supplied to the public, so then if there is a chance of any recontamination, so this chlorine will take care of the disinfection process. Okay, so therefore most of the treatment plants will add a chlorine beyond the breakpoint, that means beyond the demand. So normally a residual chlorine of 0.2 milligram per liter is required. So this is the dosage which is suggested as residual chlorine. How to find this residual chlorine means residual chlorine is equal to total chlorine added minus chlorine demand. Whereas chlorine demand is what? Chlorine demand is equal to total chlorine minus residual chlorine, and residual chlorine is total chlorine minus chlorine demand. Then how to find the amount of chlorine required means, so average flow rate or the quantity of water to be supplied to the public into chlorine concentration or chlorine dosage. Okay, so that gives the total amount of chlorine required for the treatment of 1 per day. Okay, so this can be calculated using this equation. Okay, so that is the theory part of disinfection chapter, that is module 5. So let us take up the numerical examples, some simple numerical examples on this chlorine demand. Okay, so a total of 15 kg of chlorine is used in one day to disinfect a volume of 50 million liters of water. What should be the chlorine dose? This is the problem. So let us write the data, given data. Amount of chlorine is given as 15 kg per day. Okay, so because 15 kg of chlorine is used in one day, so that means 15 kg per day. So let us convert it into milligram. Okay, milligram per day. So that will be equal to, if you convert it this kg into milligram, so it will be 15 into 10 power 6 milligram per day. Next, quantity of water or flow rate, that is equal to 50 ml. So that is 50 million liters per day. Okay, so convert this million liters into liters per day. So then that will be 50 into 10 power 6 liters per day. So now the chlorine dosage is what? What should be the chlorine dosage? This is the data. Now let us use this equation. Amount of chlorine required is equal to average flow rate into chlorine concentration. So now amount of chlorine is 15 into 10 power 6, that is equal to, and the quantity of water is 50 into 10 power 6 into chlorine concentration is C. So if you calculate it, you will get a chlorine dosage of 0.3 milligram per liter. 0.3 milligram per liter. Next, we'll take up the second problem. A water is tested and found to have a chlorine demand of 1.9 milligram per liter. If the desired chlorine residual is 0.8 milligram per liter, what is the desired chlorine dose in milligram per liter? Okay, so let us write the data now. Chlorine demand is 1.9 milligram per liter and residual chlorine is 0.8 milligram per liter, and chlorine dosage is unknown. Okay, we have to find chlorine dosage. So there is no need to convert any units now. So all are in milligram per liter. So straight away you can use the data. So chlorine dosage is given as chlorine demand plus residual chlorine. Chlorine demand plus residual chlorine. So let us substitute it. 1.9 plus 0.8. 1.9 is chlorine demand and residual chlorine is 0.8. Therefore, chlorine dosage is 2.7 milligram per liter. 2.7 milligram per liter. Next, we'll move to the third problem. The water is treated at treatment plant about 20,000 meter cube per day. The water to be treated is 20,000 meter cube per day. The chlorine usage is 6 kg per day. Okay. The residual after 10 minutes contact time is 0.1 milligram per liter. Calculate the dosage in milligram per liter and chlorine demand of water. Let us write the data. Quantity of water to be treated is 20,000 meter cube per day. So it is in meter cube per day. So we have to convert it into liters per day. So we have to multiply with 10 power 3 to convert meter cube to liter. We have to multiply with 1000. Okay, so therefore 20,000 into 10 power 3 liters per day. Next is amount of chlorine. So the chlorine usage is 6 kg per day. So that is nothing but amount of chlorine used in one day. So that is equal to 6 kg per day. So convert this kg into milligram per day. So that will be equal to 6 into 10 power 6 milligram per day. And then residual, the residual after 10 minutes contact time is 0.1 milligram per day. So chlorine residual or residual chlorine is 0.1 milligram per liter. Calculate dosage. So that is chlorine dosage we have to calculate and chlorine demand as well. Okay. So this is the problem. So let us solve this. We know that amount of total chlorine required is equal to average flow rate into chlorine concentration. So let us substitute the values. Chlorine amount is 6 into 10 power 6 milligram per day into average flow rate or total quantity of water is 20,000 into 10 power 3 liters per day into chlorine concentration, which is unknown, chlorine dosage. Okay, so therefore chlorine dosage C is equal to 0.3 milligram per liter. So this is the dosage of chlorine used to disinfect 20,000 meter cube of water per day. Okay. Next, to find chlorine demand, we know that chlorine dosage is equal to chlorine demand plus residual chlorine. So let us substitute it. Chlorine dosage is 0.3, chlorine demand is unknown, plus residual chlorine is 0.1. Therefore, chlorine demand is 0.3 minus 0.1, that will be 0.2 milligram per liter. So we know that chlorine demand is total chlorine minus residual chlorine. So total chlorine is 0.3 milligram per liter and residual chlorine is 0.1 milligram per liter. So therefore 0.3 minus 0.1, it will be 0.2 milligram per liter. Okay. So these are the simple numerical problems we have solved on disinfection of water, that means chlorine demand, especially on the chlorine. Okay. So that completes the disinfection module, not the entire module, disinfection topic. Okay. So, okay, thank you.